practically. Write this in language. An infinite plane slab. An infinite plane slab of thickness 2D carries a uniform volume charge density rho. Find the electric field as a function of y, where y is equal to 0 is at the center. Plot field versus y. So suppose this is the coordinate axis. This is suppose x, this is y, and this is z. Okay. And we have, ये थोड़ा अच्छे से बनाना होगा. We have a slab जिसका center यहाँ है. Okay. Center of the slab is this. So let us make the slab. So it is like this. So it should be parallel to this, no? Okay. So this, ये slab एक बना लो. थोड़ा अच्छे से बनाना होगा, otherwise symmetry नहीं दिखेगी. This is the slab, which is actually 2D thickness is there, and this I will have to shift little bit, right? Because I want this at the center. So how to do that? I'll make it here, okay? This will be at the center. Like this. Okay? So this is at the center. So this is infinite, okay? So how to calculate the electric field? That is the question. So because it is infinite in this dimension, this is suppose this is x-axis. This is x-axis. Okay. So now you have to make a cylinder. Cylinder will be perfectly fine for this. So make a cylinder that is coming out of this like this. It is perpendicular. So this cylinder is parallel to, देखें geometry समझ पा रहे हो आप? This cylinder is parallel to which axis?
Y.
Y axis. Very good. So let us take this small area as capital A. So are you able to understand कि इस सिलेंडर का थोड़ा सा पार्ट इसमें रहेगा? कितना पार्ट? बोलो भाई. How much? 2D. So 0 is at the center of this and 2D is the thickness. So D part is, so it is like this. If I make it in 1D, it is like this. This is 0 origin and this cylinder part will be inside the, and this cylinder part will be inside it. Okay. So this part of the cylinder will be inside and the outer part will be this. So this part will be 2D. This is Y axis. समझ आ रहा है? If I make this same thing in this dimension. So if you apply, so what you will have to do is make the Gaussian, this Gaussian thing, first of all, calculate the field inside. So for that, ये length को किससे होना होगा छोटा? It should be less than 2D, yes or no? भाई, if your point P is inside of this, so it is like this. This is the width of the block, 2D. So first of all, get the field here and then get the field here. So P point should be at two distances. First of all, take this as Y and then take this distance as Y. Okay? ठीक है? So when Gaussian surface is inside, that means when Y is less than D, when Y is less than D, what will happen? Closed integral E dot dA will be equal to
Y is less than 2D, na, sir? Or
no, Y is less than D because this is the center, na? So distance will be measured from the origin. ये फिगर देखो ना, समझ आया या नहीं?
मतलब सर एक पोर्शन में से ले रहे ली होगा तो उससे कम ऐसा दिखा रहे हैं ना?
ये 2D है, ये सेंटर है, तो Y यहां लोगे, this is origin, this is Y. So
Less than
Y is less than D.
सर सिलेंडर माइनस बाई की तरफ रखा हुआ है क्या? डी डिस्टेंस पे.
सिलेंडर इज अलोंग द Y. ये एकदम बढ़िया फिगर बना दिया आपके लिए 2D में, क्योंकि मैंने Y एक्सिस पे ही बना दिया ना ऐसे. भाई अभी तक क्या था? X एक्सिस ऐसे थी, जब मैंने Y ऐसे बना दिया, इसमें क्या दिक्कत है? ये समझाओ, ऐसे चौक की तरह रखा हुआ है.
यस सर.
चौक भी तो सिलेंडर ही है. और
यस सर.
ये वाला साइड ऐसे आ गया है. दिस इज 2D. ऐसे चौक अंदर रखा हुआ है. दिस इज द गॉसियन सिलेंडर. व्हाई? क्योंकि इस पॉइंट पे तुम्हें निकालना है, तो गॉसियन सिलेंडर शुड पास फ्रॉम दैट पॉइंट जहां पे इलेक्ट्रिक फील्ड निकालनी है. ओके?
सर जैसे ब्लैक बोर्ड सर बाई एक्सिस मान लेते सर, उस पे खड़ा करके चौक रख देंगे सर, उस टाइप से रखा हुआ क्या सर?
ये जब सामने ये दिख रहा है, इससे अच्छा क्या हो सकता है? तुम्हें कुछ करने की जरूरत ही नहीं है. ये एक्सिस वाई एक्सिस है और सिलेंडर ऐसे रखा हुआ है.
वो
क्या
हम
कह रहे
मतलब
हो?
पूछ रहे हैं सर, मतलब बाई एक्सिस के सेंटर पे रखा हुआ है सर सिलेंडर।
ओरिजिन पे रखा हुआ है। वाई एक्सिस का सेंटर क्या होता है? ओरिजिन होता है। ये जो ओरिजिन है, बीचों बीच वाला पॉइंट, ये यहां रखा हुआ है। ओके, तो
ओके सर।
व्हेन यू टेक इट, इमेजिनेशन थोड़ा चाहिए होगी, थोड़ा आपको इमेजिन करना होगा। ये तो स्ट्रेट फॉरवर्ड है कि ये वाली चीज जो है, ये वाई एक्सिस को मैंने ऐसे बना दिया तो ये वाला पोर्शन आपको ऐसे दिखने लगा। तो अब ब्लॉक ऐसे रखा हुआ है। हम्म उसके अंदर एक सिलेंडर ले लिया इतना बड़ा। ओके, दिस इज,
यस सर, गुड।
सो दिस विल बिकम, अब अगर सपोज इलेक्ट्रिक फील्ड यहाँ पे ई है, तो डीए भी सेम डायरेक्शन है। सो इट विल बिकम क्लोज्ड इंटीग्रल डीए, क्लोज्ड इंटीग्रल डीए। क्या बन जाएगा? हेलो?
यस सर।
क्लोज्ड इंटीग्रल डीए
Rho is equal to rho
is equal
into
to, so
rho
what will be this? Rho into,
integration
what is this cylinder? Pi,
पाई आर स्क्वायर एच।
pi a लिख लो ना, इस क्रॉस सेक्शन
यस
को
सर।
a ले लो।
यस सर।
Take this cross section as a, so pi a into y. So y this side and y this side, how much it will become? 2y. Total length of this will become 2y. This is origin. Okay. So what about this side? E into
ए।
E into 2a, because field is this side, field is this side. Yes or no? So this side also, so it should be written as this: EA plus EA is equal to rho pi a by 2y. So a 2EA is equal to rho pi a 2y by epsilon naught. Okay. Yes. A and A will cancel. 2 and 2 will cancel.
rho pi r.
Pi is not required. So E will become rho y by epsilon naught. But this is the magnitude. If you want to draw the direction, so it will be for y greater than 0, it will be E is equal to rho y by epsilon naught y cap. And for y less than 0, it will be E is equal to rho y by epsilon naught minus y cap. ये दो डायरेक्शंस हो जाएंगे, क्योंकि फील्ड इस साइड जब यहां से राइट हो तो फील्ड इधर है, यहां से लेफ्ट हो तो फील्ड इज दिस साइड। So दोनों बातों को बताने के लिए you have to write it like this or put a mod. You can write it like this also. If you want to put a vector, put a mod here. That is okay. For right, it will become positive y, and for left, it will become
Sir, pi factor?
अरे pi was not there ना. Area तो capital A पूरा पूरा लिखा है ना.
Yes.
No requirement of pi.
Sir,
देखो ये
please
बहुत
explain this term rho pi a 2 by epsilon naught.
charge is equal to rho into volume.
Yes, sir.
मैंने गलत लिख दिया है क्या? सही तो है. So this is rho into volume is area into length.
Yes, sir.
So rho की जगह rho, pi is not there. Area की जगह area, length की जगह
Yes,
2y.
sir. Yes, sir. Up to.
और ये सब कब है? When y is
Less
less
than.
than.
तो सर ये सेकंड वाली तो लाइन में भी ये पाई नहीं होगा ना सर? ये प्लस ए वाली
हाँ
में.
हाँ हाँ सॉरी, वो पाई मैं पहले एक बार गलती से लिख दिया ना, तो हर जगह ही
ओके
हो
सर.
गया वो.
ओके सर.
और दूसरा बड़ा मजेदार केस है when y is greater than d. That means your Gaussian will come out of this, right? ऐसे हो जाएगा ना, ऐसा. बोलो भाई.
सर.
ठीक. जब ग्रेटर होगा तो देखो बड़ा इंटेलिजेंटली लिखना होगा, बिकॉज इंटीग्रल E dot dA will be Q enclosed over epsilon naught. Huh? So you will get E dot dA on two sides, here and here. This is direction E. So you'll get 2EA for sure. 2EA. And field.
Rho 2a into 2d.
So it will become 2EA and 1 by epsilon naught rho into 2D. अब ये बड़ा important है देखना, because only this much of the cylinder will give the charge. Charge is filled only up to this. This is very important. So 2 and 2 will cancel
Into 2a.
into 2A. Okay. 2D into A. 2D into
Last time we
तो 2a ही होगा.
no. For charge, भाई charge के लिए तो you are writing the volume ना. So suppose this is A and this is 2D. So what is volume? 2D into A.
Okay, sir.
क्या कह रहे हो कंचन आप?
नो सर, वही कंफ्यूजन था मेरा. 2A आएगा, क्लियर हो ये आपने बताया.
तो A से A भी कैंसिल हो जाएगा and E will become rho D upon epsilon naught. This will become the field. And it is obvious that the field should become finite. Field कैसी हो जानी चाहिए?
Uniform.
No, finite. It should become finite. After, भाई it is infinite sheet ना, तो बाहर निकलने पे तो same case follow होना चाहिए ना, that we have done, already done. Now ask if there is any doubt. Tell me.
Sir,
after
the distance y is greater than d,
the
electric field do not depends sir, upon the distance
हाँ,
in this case.
right. Because once you come out,
Yes, sir.
whole of the charge which is contributing has been taken into account.
Yes, sir. Sir, as you told for that sheet by making it.
हाँ, same. Because this is also infinite sheet, na? This is also
Yes, sir.
infinite.
Okay, sir.
Only finite. Before it was a thin sheet, now it is
Yes, sir.
thick. Only
Yes, sir.
that. Otherwise, it is infinite. Okay? Running
sir.
infinite. तो अब ये मिटा दूं?
Sir.
और बहुत ही अच्छा है इसका प्लॉट. देखो जरा. The plot. The field is 0 at the center. As you know, it depends on y. So if y is 0, then field is 0. It starts from 0, then it is proportional to y. Up to what? This is y-axis. Up to d distance, it is proportional. And after that, it becomes constant. देखो कितना बढ़िया graph है. And in opposite side, it will go like this up to minus d, and then it will become constant. So this is the graph between electric field and the distance y. तो बिल्कुल एग्जाम वाला क्वेश्चन है ना. Just a system can be given and which one of the following graphs explain the electric field of the system. So as you move from the center to the edge, the electric field grows linearly and then it becomes constant. And similarly, this side also, the same thing happens. Is it okay?
Yes.
Chalo. So let us take another question. This is a very nice question, no? So that's why I make it a three-dimensional figure. Otherwise, it is very difficult to explain, na? So कई बार you have to spend time just to explain. So now another question is like this. Two spheres, each of radius capital R, so these are two spheres. This is having charge density rho and this is having minus rho, and they both are of radius capital R. Okay. Two spheres, each of radius capital R, carrying uniform charge density plus rho and minus rho respectively, are placed so that they partially overlap show that the field in the region of overlap is constant. It is given that this distance between them is d. This vector is given actually to be d vector. This vector is d vector. And they are saying, let me actually, figure is very important in this question. Let me make it little bigger to make you understand. So suppose this is one sphere, this is another sphere, this is having charge density rho, this is having charge density minus rho, and these are the centers of the two sphere, and they have given that this vector is d. Now they are saying that prove that if I calculate electric field at any point in this region of overlap, this is the region of overlap, इसके किसी भी पॉइंट पे अगर मैं इलेक्ट्रिक फील्ड कैलकुलेट करूं, तो सपोज दिस इज O डैश, and this is suppose, let us take it R plus, let us take it R minus, or we can take R1, R2 also, no problem. So they are saying if you calculate the electric field here, it will be constant. Constant means it will not depend on the changing distance. Okay? That is the question. समझ आ रहा है? So please understand, at point P, the electric field is rho plus minus rho. This is the electric field.
Yes, sir.
Vector sum. And here electric field is rho R plus by 3 epsilon naught. And here it is minus rho R minus by 3 epsilon naught. Because you know, if you have a sphere of charge density rho, from the center to any point which is inside any point P, the electric field is given by rho R by 3 epsilon naught. This is the electric field, correct? Now here in this triangle, this is the triangle. This is D, this is O, this is P, and this is O dash. This is R plus, this is R minus. Okay. So if you apply triangle law, tail to head is equal to tail to head. So tail to head plus tail to head is equal to tail to head. This is the triangle law. So you can write here rho by 3 epsilon naught times D, which is constant, independent of distance, only depending on the distance between two spheres, which is fixed. So this is also a very nice question. Yes? Is it okay?
Yes, sir.
तो ट्रायंगल लॉ देख रहे हो, जब यहां लगाओ तब समझ में आता है कि ट्रायंगल लॉ क्या होता है, अदरवाइज तो आप क्लास 12 से ही सीखते आ रहे हो. कोई डाउट है तो पूछ लो, इफ यू हैव एनी डाउट. नाउ ठीक है, क्लियर है भाई?
सर एक डाउट है,
हाँ
इसमें एक स्फेयर की चार डेंसिटी रो है और एक की माइनस रो है,
हम्म
तो जो पॉइंट पी के ऊपर इलेक्ट्रिक फील्ड की डायरेक्शन होगी दोनों की तरफ से आउटवर्ड ही होगी।
नहीं, तो मैंने ये वेक्टर आउटवर्ड
अच्छा
लिया है,
अच्छा, ये वेक्टर है, फील्ड नहीं है, ठीक है सर।
तो फिर मैंने रो का साइन ले लिया है ना,
यस सर,
तो
गॉट इट।
बात तो सेम ही है। दिस इज
यस
नॉट
सर।
द डायरेक्शन ऑफ फील्ड।
हम्म।
सो फील्ड की डायरेक्शन क्या है, देखो, ई माइनस रो की डायरेक्शन क्या है,
यस
इट
सर।
इज रो माइनस आर by
यस सर।
f3 epsilon naught. So obviously, if you check the field direction at this point, due
दैट
to
विल बी।
this, it is this side.
यस सर।
Okay.
यस।
Okay. Now we will move from slowly move from electric field to electric potential, and we are discussing right now electrostatic field. We are discussing right now electrostatic field, right? Hmm? Electrostatic field पढ़ रहे हैं ना?
Yes, sir.
Yes, sir.
So electrostatic field will have a very important property, because you know the curl of field, curl of E, this will be always 0 for any electrostatic field, because later on you will know that in Maxwell's equation that del cross E is actually minus del B by del T. Magnetic field is when there is moving charge. Moving charge produces current and current gives magnetic field. So since the charge is static here, so this side becomes 0. And for any electrostatic field, so बहुत सारे question तो इस पे ही पूछे गए हैं previous year में, that which one of the following represents electrostatic field. So you should know del cross E in all three systems. Cartesian. इसीलिए मैंने आपको जो 2 पेज भेजा है वो अपनी कॉपी में पूरा नोट कर लो या फिर चिपका लो। ओके, एक एक करके वो फॉर्मूले जो है यूज होते रहेंगे एंड कंटिन्यूअसली यू विल बी विजिटिंग दोज फॉर्मूला। सो व्हाइल गोइंग टू एंड फ्रो ऑलवेज स्लोली एंड स्लोली यू विल रिमेंबर। ओके, जितना रिक्वायर्ड है वो याद हो जाएगा। सो कार्टेशियन एंड देन स्फेरिकल, पोलर एंड देन सिलिंड्रिकल। सिलिंड्रिकल सो कार्टेशियन का डेल क्रॉस ई तैयार कर लो, स्फेरिकल पोलर का डेल क्रॉस ई रेडी, एंड इस सिलिंड्रिकल का रेडी। तीनों टाइप के कोऑर्डिनेट सिस्टम में this should become 0 if the field is electrostatic. Okay, and from this comes the concept that well, let me give you a field to check. Try this. Check whether it is an electrostatic field. E is equal to K x y x cap plus 2yz y cap plus 3xz z cap. Check karo. So when you do del cross E, what you will get? In Cartesian, it is x cap, y cap, z cap, del by del x, del by del y, del by del z, k x y, k 2yz, 2k yz, and 3k xz. 3k xz. चेक करो ये 0 आना चाहिए. This should come out to be 0. And also, I am giving another one also. That E is equal to K y square x plus 2xy plus z square y cap plus 2yz z cap. ये भी check करो. These both are actually. Check it, somebody quickly.
पहला वाला तो 0 नहीं आ रहा सर.
हाँ सर पहले वाला 0
यस सर नहीं आ रहा.
The first one is not zero.
Okay, so this is not electrostatic field, okay? And second one? ये कर्ल की डेफिनेशन है कार्टेशियन के लिए. So curl of a vector is this. Curl of a vector E. This is called curl
Sir.
of E. What about this?
टर्म y स्क्वायर है ना.
This
See-
is 0, sir.
Yes, post it in the group. So now you know how to check whether a field is electrostatic. How to check?
The
How you
curl
will
of E
curl of E should be
zero.
0. If curl of E is not 0, that means you are getting something here which is equal to minus del B by del T. So that means magnetic field is also there. So that means it is not electrostatic field but electromagnetic field. Okay? समझ आया?
Sir, this means the charge is in motion.
Charge is in motion. And there is some current, and because of, I mean, that is not the case. Case is that
Sir.
changing magnetic field may produce electric field. Na? This is
Yes, sir.
Faraday's law.
Yes, sir.
This is Faraday's law that changing magnetic field may produce the electric field. So that means the changing magnetic field has produced that electric field, not the stationary charge. That is the meaning.
Okay, sir.
You can write it also, what I have said. Okay.
सर सेकंड आ रहा है.
तो मतलब सेकंड वाली फील्ड इलेक्ट्रोस्टैटिक है फर्स्ट वाली फील्ड इलेक्ट्रोस्टैटिक नहीं है। ओके, अब यहीं से बिकॉज कर्ल ऑफ अ क्वांटिटी 0 है, ध्यान से देखना, कर्ल ऑफ अ क्वांटिटी इज 0, so I can write curl of some minus gradient of V is equal to 0, because curl of gradient is always 0. Okay, so that means I can write E as this, yes or no? So later on you will understand that for electrostatic field you can write a potential V which is equal to E is equal to minus grad of V, only for electrostatic field. Seeing ki right hand side 0 aa raha hai, curl of E is 0, so I can write for the E some grad of V, because curl of grad of V is always 0, so that means it will represent, grad of V will represent electric field, and if you put the minus sign then it will also include the direction of electric field. Okay, so minus grad of V will give the direction of electric field. So अब इस potential के बारे में next discussion शुरू करना है. Okay, चलो ठीक है. Okay, thank you. From next class I will discuss potential. Okay, thank you. Good night.
थैंक यू
सर
थैंक यू सर।
हाँ,
सर वो शीट में से कुछ डाउट्स थे, वो आपसे मैं कैसे सर पूछूं?
कौन सी शीट से?
जो आप में जो गूगल जो क्लासरूम में जो लास्ट ईयर वाले जो
सारे
करवाए थे ना
ग्रुप
सर?
में ही डालो और सब लोग आपस में डिस्कस करो, मैं भी उसमें मैं भी बता दूंगा. ठीक है,
ठीक ठीक ठीक।
सबके
ओके सर।
सभी लोग एक्टिविटी अपनी वैसी ही रखो, जितना लर्निंग होगा, एक क्वेश्चन डालते हो, कई लोग सीखते हैं उससे. ओके,
श्योर सर, श्योर सर।
ओके,
थैंक यू सर।
ओके. क्वेश्चन और सॉल्यूशन दोनों डाल दो, देन यू कैन डिस्कस. हाँ,
ओके सर, ओके।